The most recent milestone in ship design provides a solution to the problems encountered with the supertankers. The seasnake concept is a novel marine transportation system that is designed to lower the costs of delivering oil from production sites to refineries or storage facilities, while greatly expanding its accessibility to draft-restricted harbors. It is particularly well suited to provide storage at the foot of platforms and can deliver the oil from offshore drilling sites to shore. The essence of the system is a flexible modular ship consisting of a traction unit pulling a train of specifically designed detachable barges, closely coupled to each other by a mechanism equivalent to a ball and socket that, when assembled, behaves as a single hydrodynamic unit. The mothership, or train, remains at a suitable anchorage outside or inside the harbor, while the last unit of the train, which is a modified powered barge, is used as a tug for delivering one or more barges into the harbor and returning any empty ones to the train. The advantages of the seasnake concept for moving bulk cargo are analogous to the advantages of the railroads without the disadvantages of being restricted to established railroad tracks. In another sense, the seasnake also has some of the advantages found in the container ship concept. The ship does not have to wait while the containers are being filled or emptied. It merely delivers the full containers and picks up the empty ones. Both the cost of construction and the operating costs of the seasnake will be considerably less than that of a conventional tanker. This ship can occupy practically all the niches in the oil transport business. It can function as a supertanker when configured as a long train with a 45-foot draft, or it can function as a small coastal tanker when configured to its smallest dimension, that consists of a traction unit joined to a caboose. It is this versatility, plus its low draft, that makes it attractive to ship operators.
The seasnake concept is a unique system of transportation at sea. The system is comprised of a traction unit at the head of a train of barges. The traction unit is coupled to the barges, and the barges are coupled to each other through a system of ball and socket joints. The socket joint is positionable in a vertical direction, and on the adjacent barge, the ball unit then can be attached to the socket unit in such a way that the socket unit is adjusted to the draft of the two adjacent units. That gives the system a lot of flexibility so that barges of different drafts can be coupled together. The ball and socket units function together to permit the barges to roll independently of one another and to permit them to pitch independently of one another. However, the translational motions in the ship, and particularly the fore and aft direction and the sway sideways, are restrained so that the net effect of all of this coupling is that the longitudinal bending forces and moments in the entire barge train are minimized. This has the advantage of permitting the barge units to be built to lighter scantlings or lighter structural members, so that the cost of each individual barge unit would be less than it would be if the entire train were one solid unit.
The real advantage of the system is its flexibility. The ability to leave a barge at a location while it's being loaded or unloaded, or to serve multiple locations while keeping the rest of the system going. That to me is the real advantage of the system.
I've worked with seasnake in the past in developing concepts for new markets and markets that the seasnake could operate in, as well as providing some engineering support in terms of bringing this visionary idea to something that's practical and workable in terms of building an operation. It's similar to a railroad train in the sense that there's a tractor or a tug that pulls a series of smaller barges behind it. and they're very closely coupled together, so they can so they're very efficient in terms of structure and operation. At the same time, like a train, the smaller barges can be left for extended periods while the main unit is doing other work elsewhere. It's probably most similar to a tug and barge, and that's about where the similarity ends. This is like a ship in many ways, but like a barge in other ways, but really more like a railroad train or some certain other type of what we call modularized cargo ships. But this, the seasnake can cover things with small barges, containers, liquid bulk cargoes, dry bulk cargoes, break bulk, and other items. The fact that the ship can break apart, the seasnake can break apart and leave the other elements behind and continue work is a major difference, which is pretty much only seen on the inland river barges. Its primary advantage is that it's a relatively flexible size ship, meaning that it can go from a one barge unit to a multi-barge unit, let's say 5 barges, which means it can effectively function as what we would call a handy size to a Aframax size or Panamax size vessel. The flexibility and cargo range is quite unique in a lot of ways. In terms of dimensions, the seasnake can fit into most ports, depending on the draft and the size of the ports. Some ports are too small to handle the larger seasnake units. But in that respect, the seasnake can also break apart when it goes into ports, meaning that it can access much smaller ports than typical large vessels.
The relative low draft and low beam of the barges, unlike conventional supertankers, gives them access to most harbors, as well as transit through the Panama and Suez canals, and many other draft-restricted passages. Presently, there are projects in Texas, Arabia, and other places to build offshore terminal islands for unloading or loading large tankers, and piping the oil from or to shore. With the seasnake concept, this would be unnecessary. Also, the access to limited dock space for loading and unloading is greatly increased. The powering requirements, as determined from tank testing at the University of Michigan, are similar or somewhat less than that of a conventional tanker of the same displacement, but of a much larger draft. However, when we compare the power requirements of the seasnake with any tanker of the same displacement and low draft, the advantages of the seasnake become readily apparent. On the other hand, the power requirement of the seasnake system is considerably less than the power requirement of an integrated tug barge. The cost of the ship has been determined to be about 20% less than a conventional tanker. The size of the individual modules is just 260 feet long, and any shipyard along the Mississippi can build them. Initially, the ship was conceived with a draft of 45 feet and a beam of 100 feet, and was designated as the SS-45. Later, it became apparent that for many services, a lower draft would be required. A geometrically similar model was then conceived with a 35-foot draft and a 77.7-foot beam, which was designated as the SS-35. The hull's transverse underwater section is circular. This maintains hull continuity as the barges roll relative to each other. The water does not know that the barges are rolling. The barges are coupled to each other by a ball joint, situated at the center of the circle, defined by the hull's underwater cross-section. This allows relative rotational motion between adjacent barges in the 3 coordinate planes, pitch, yaw, and rolling, but excludes the translational motion of relative heaving and surging. This free rotation of adjacent barges about their connection reduces dramatically wave-induced dynamic torsional and bending stresses in the hull. In effect, the ship behaves as a flexible floating string,